Our objectives in this lesson are the following. Solve for the future value and present value of general ordinary annuity. Let's have a quick review. In my lesson, Introduction to Annuity, I have discussed that annuity can be classified according to the duration, payment interval, and interest conversion, and according to the time of payment. Today's discussion will focus on certain, general, ordinary annuity. Let us review the difference of simple and general annuity. Simple annuity is an annuity where the payment interval coincides with the conversion period. Example, loan payable every month with interest that is compounded monthly. So the payment interval is monthly and the conversion of interest is also monthly. They coincide. General annuity is an annuity where the payment interval does not coincide with the conversion period. Example, loan payable every month with interest that is compounded quarterly. The payment interval is monthly, but the interest conversion is quarterly. They do not coincide. This is an example of general annuity. Let us solve first the future value of general annuity. In my lesson on simple annuity, I introduced the formula for solving the future value. Here are the corresponding meaning of each letter and the corresponding value of M depending on the conversion period. Here is the formula for the future value of general annuity. Has resemblance, isn't it? It is because the only difference between simple and general annuities is the interest to be used. Let me explain. By the way, F here is still the future value and A is the amount of annuity. R over M here, which is the nominal rate divided by the number of conversions per year, is actually the interest rate. So here I used letter I. It is the equivalent interest rate per payment interval. Remember that in general annuity, the payment interval does not coincide with the conversion period. So we have to determine first the equivalent interest rate per payment interval. In simple annuity, since the payment interval coincides with the number of conversions, I use the value of M instead of introducing another variable. In simple annuity, M is equal to T, where T is the frequency of payments in a year. N is the term of the annuity or the number of years paying the annuity. Multiplying M and N here is just the same as multiplying T and N. Their product is the total number of payments. Just remember, the exponent is the total number of payments. And you can solve that when you multiply the frequency of payments in a year by the number of years paying. Now, the question is how to solve for the value of I. In my video, Compounding More Than Once a Year, I explained how to determine equivalent rate. Or, you may use this formula. I is the equivalent interest rate per payment interval. R is the nominal rate. M is the number of conversions per year. And T is the frequency of payments in a year. Let's have an example. Chris and Chris are preparing for their 25th wedding anniversary. They deposit 2,000 pesos every end of the month in a bank that pays 4.5% compounded quarterly. How much will their fund be after 6 years? Let us analyze first the scenario. The payment is done every month and the interest is compounded quarterly. Payment interval is monthly. Conversion of interest is quarterly. They do not coincide, so this is a general annuity. Now let us determine the given. First thing that we have here is 2,000 pesos, the amount of the annuity, letter A. Next, this is done every end of the month. There are 12 months in a year, so the frequency of payments in a year is 12. That is our T. In a bank that pays 4.5%, this is the nominal rate, letter R. Converted to decimal, 1, 2, 0.045. And this is compounded quarterly, meaning our M is equal to 4. How much will their fund be after 6 years? So the term of the annuity is 6 years. This is our N equal to 6. How much will their fund be? We are looking for the future value. First thing to do is to solve for the value of I. Let us substitute our values here. Our R is 0.045. Our M is equal to 4. M again is equal to 4. And our T is equal to 12. Let us use our calculator to solve this. This time, I will be using an emulator from Casio model FX991ES Plus. Let us start encoding, open parenthesis, 1 plus fraction bar. The numerator is 0.045. Cursor down, denominator is 4. Cursor to the right, close parenthesis. Next, we have the exponent in fraction form. The numerator is 4. Cursor down for the denominator, which is 12. Cursor to the right, 1 more, minus 1 equals 0.0037360247. Quite long. If you can use this all, much better. If not, I suggest you use at least up to 6 decimal places. Now let us solve for the future value. Let us recall the formula. A is 2,000, and then we have the value of I, this one, and then our T is the frequency of payments, which is 12, and then our N is the number of years paying, that is 6, minus 1 divided by, again, the value of I. Let us use again our calculator. We have 2,000, open parenthesis, fraction bar, open parenthesis, 1 plus 0.003736. Close parenthesis, exponent is 12 times 6. Close parenthesis, cursor to the right, minus 1. Cursor down, 0.003736. Cursor to the right, close parenthesis, equals 164,876.29. That is our future value. Let us have another example. Mr. and Mrs. Cruz want to teach their son the value of saving. They opened an account that pays an interest of 8% compounded semi-annually. Their son will deposit 1,000 pesos every 3 months. How much money will there be after 3 years? Let us analyze the situation. It says here every 3 months. This is the payment interval. And the interest is compounded semi-annually. So every 3 months is quarterly, and then this one is semi-annually. They do not coincide. This is a general annuity. Let us determine the given. First is we have here 8%. This is our nominal rate. 1, 2. This is 0.08, our R. And then we have semi-annually, meaning our M is equal to 2. And then we have here 1,000 pesos. This is the regular deposit. This is our A, the amount of annuity. And it is deposited every 3 months. Meaning, if it is every 3 months, this is quarterly. And there are 4 quarters in a year, so our T is equal to 4. And then we have here 3 years, the term of the annuity. This is our N. How much will there be? So we're looking for the future value. Again, our formula for I, let us substitute our given here. Our R is equal to 0.08. Our M is equal to 2. M again is equal to 2. And our T is equal to 4 minus 1. Let us use our calculator to solve this. Open parenthesis, 1 plus fraction bar, 0.08. Cursor down, we have 2. Cursor to the right, close parenthesis. Our exponent is in fraction form. 2 for the numerator, cursor down, 4 for the denominator. Cursor to the right, once more, minus 1 equals. Our I is 0.01980390272. This time, let us solve for the future value. Let us substitute our values. Our annuity is 1,000. Our I up to 6 decimal places, 1, 2, 3, 4, 5, 6. Rounded off, this will become 4. And then our T is equal to 4 and our N is equal to 3. Minus 1 and then divided by our I again, rounded off to 6 decimal places. Let us calculate this. Let us input our values. We have 1,000, open parenthesis, fraction bar, open parenthesis, 1 plus 0.019804. Close parenthesis. Our exponent is 4 times 3. Close parenthesis. Cursor to the right, minus 1. Cursor down, 0.019804. Cursor to the right, close parenthesis, equals 13,397.32. This is our future value. Now let us discuss about the present value of general ordinary annuity. Here is the formula, and once again, here is the formula for computing I. P is the present value, A is the annuity, I is the equivalent interest rate per payment interval, T is the frequency of payments in a year, and N is the term of the annuity or number of years paying. And then R here is the nominal rate, and M is the number of conversions per year. Let us have an example. Mom Jenny would like to buy a laptop for her online class. How much is the cost of the laptop if her monthly payment is 2,000 pesos with interest rate of 3.5% compounded quarterly and payable for 2 years? So let us analyze. The annuity is monthly and the interest conversion is quarterly. They do not coincide, so this is a general annuity. Let us determine the given. The first word that we have here is monthly. There are 12 months in a year, and that is the frequency of payment. So our T is equal to 12. And then we have here 2,000 pesos. This is our annuity. The interest rate is 3.5%. This is our nominal rate. Let's convert this to decimal. 1 to 0.035. Compounded quarterly, meaning our M is equal to 4. Payable for 2 years, meaning our N is equal to 2. This time we are looking for the present value. To solve for I, let us recall the formula and let us substitute our values here. Our R is 0.035. Our M is equal to 4. M again is 4 and our T is equal to 12. Let us solve for the value of our I. We have open parenthesis 1 plus fraction bar 0.035. Cursor down. The denominator is 4. Cursor to the right. Close parenthesis. Our exponent is in fraction form. 4 over 12. Cursor to the right, once more, minus 1 equals 0.00290820083. Now let us solve for the present value. Let us recall the formula. Let us substitute our values here. Our A is 2,000. We just computed for the value of I, rounded off to 6 decimal places. Our T is 12 and our N is 2. Let us compute. We have 2,000, open parenthesis, fraction bar, 1 minus, open parenthesis, 1 plus 0.00298. Close parenthesis. Exponent is negative 12 times 2. Close parenthesis. Cursor down. 0.002908. Cursor to the right. Close parenthesis. Equals 46,298.32. This is our present value. Let us try this one. To renovate their house, Krisha applied for a loan payable in 6 years. Quarterly, she will pay 15,302.42 pesos. If the loan is compounded semi-annually at 6.8%, what is its present value? Let us analyze. So the payment interval is quarterly, but the conversion period is semi-annually. They do not coincide. This is a general annuity. Let us determine the given. The first thing that we have here, 6 years, payable in 6 years. This is our N. This is quarterly, meaning this is 4 times in a year. T is equal to 4. 15,302.42 is our annuity. Compounded semi-annually, meaning our M is equal to 2. At 6.8%, this is our nominal rate, 120.068. And we are looking for the present value. First step is the value of I. Let us substitute the values here. Our R is 0.068. Our M is 2. M again is 2. And our T is equal to 4. Let us compute. We have open parenthesis, 1 plus fraction bar 0.068, cursor down, 2, cursor to the right, close parenthesis, exponent is in fraction form, 2 over 4, cursor to the right, once more, minus 1 equals. We have 0.01685790551. Now, let us recall the formula of the present value. Substituting the values here, our A is 15,302.42. I rounded off to 6 decimal places. Our T is 4 and our N is 6. Let's have our calculator once again. Let us compute. We have 15,302.42, open parenthesis, fraction bar, 1 minus, open parenthesis, 1 plus 0.0168858. Close parenthesis, our exponent is negative 4 times 6. Close parenthesis, cursor down, 0.0168858. Cursor to the right, close parenthesis, equals 300,000.177 or 300,000.18. This is the present value. Let us do extra challenge. An automatic washing machine costs 18,300 pesos on a cash basis. The store also offers an installment plan. A down payment of 3,000 pesos and monthly of 1,500 for 1 year at 1.5% interest rate compounded quarterly. How much is the difference between the cash basis and the cash value? Which will you prefer, cash or installment? Let us analyze. The annuity is monthly and this is compounded quarterly. So indeed, this is general annuity. Let us determine the given. The first thing we have here is 18,300. This is the cost on cash basis. And then there is also installment plan. There is a down payment of 3,000 pesos monthly. So meaning 12 months in a year, our T is equal to 12 of 1,500. This is our annuity for 1 year. So our N is equal to 1. At 1.5%, this is our nominal rate, 120.015. Compounded quarterly, meaning our m is equal to 4. So first thing that we have to do is to solve for the value of I. Let us substitute our values here. Our R is equal to 0.015. Our M is equal to 4. M again is 4 and T is equal to 12. Let's have our calculator to answer this. Open parenthesis, 1 plus fraction bar 0.015, cursor down, 4, cursor to the right, close parenthesis. Exponent is in fraction form, 4 over 12. Cursor to the right, once more, minus 1 equals. So we have 0.001248444074. Quite long, isn't it? I will teach you a technique so that later we don't have to input again these numbers. So what I am going to do is to store this in my calculator. I'm going to press Shift and then this one. And then I'm going to choose a letter from A to F. I'll choose letter A. Notice here, answer, then there's an arrowhead, letter A, meaning this value is stored in letter A of my calculator. Now let us solve for the present value. Let us substitute the values. Let us input that in our calculator. We have 1,500, open parenthesis, fraction bar, 1 minus, open parenthesis, 1 plus. Our value of I is stored in letter A. So I'll just press alpha and then letter A here. So there is my letter A. So the value of that is the one that I stored earlier, the value of our I. Close parenthesis, exponent, negative 12 times 1. Close parenthesis. Cursor down, I again, and that is alpha A. Cursor to the right, close parenthesis, equal sign. So we have 17,854.78. That is just the present value. But we are asked of the cash value. If you can still remember in our previous lesson, cash value is equal to the down payment plus the principal value. So the down payment is 3,000 plus the principal value, and this is equal to 20,854.78. If cash on hand will suffice, then it is better to buy the automatic washing machine in cash, or wait until you have sufficient cash than to buy it in installment. Why? Because the cash basis is less than the cash value. For the summary, here are the things that we discussed in this lesson. Take time to understand this. The formulas for future value, present value, and the equivalent interest rate per payment interval. Now, it is time to check your understanding. Pause this video for more time. Let us answer. Solve for the future and present value of an annuity worth 5,000 pesos every month at 9% compounded semi-annually for 10 years. So every month is the payment interval, but the conversion period is semi-annually. They do not coincide. This is a general annuity. Let us identify the given. First one, we have 5,000 pesos. This is our annuity. And this is done every month, 12 months in a year. So the frequency, T is equal to 12. At 9%, this is the nominal rate, 0.09. Compounded semi-annually, our M is equal to 2. For 10 years, this is the term of the annuity, N is equal to 10. Let us solve for the value of I, substituting the values here. And let us calculate, open parenthesis, 1 plus fraction bar 0.09, cursor down, 2, cursor to the right, close parenthesis, exponent in fraction form. We have 2 The denominator is 12. Cursor to the right. One more. Minus 1. Equal sign. We have 0.00736312302. Very long. So what I'm going to do again is just to store this one. Shift. And then this button. And then I'll choose letter B this time. So this answer is stored in letter B. Now let us solve for the future value. Let us substitute our values. Let us solve. We have 5,000, open parenthesis, fraction bar, open parenthesis, 1 plus. Our I is stored in letter B. So alpha and then B. Close parenthesis, exponent is 12 times 10. Cursor to the right, minus 1. Cursor down, alpha, B. Cursor to the right, close parenthesis, equals 958,638.08. That is our future value. Let us continue. Let us solve for the present value. This time, the formula is, and let us substitute our values here. Let us compute 5,000, open parenthesis, fraction bar, 1 minus, open parenthesis, 1 plus. Our I again is stored in letter B, alpha B. Close parenthesis, exponent, negative 12 times 10. Close parenthesis. Cursor down. Our I again is stored in letter B, so alpha B. Cursor to the right, close parenthesis, equals 397,492.44. Gets? Our next lesson is fair market value of a cash flow.